And now be live. Great. Just give me thumbs up if it's okay. Be live. And please mute yourself, Sebastian. Just give me thumbs up if it's okay. And please mute yourself, Sebastian. Okay, great. So, hi, I'm Jakub. I'm connecting to you from Prague. It's early in the morning in here, so if I fall asleep in the middle of the presentation, please forgive me. But I already had my morning coffee, so it should be okay. So I will be talking about Pester. Pester is a testing tool that everybody in the PowerShell community talks about. If you want to do testing, you choose Pester. And I'm very happy for that because I'm one of the owners of the project. So this is me on the internet. I am Microsoft MVP, and I go on the Twitter on the handle no handle, but it's spelled no HVND because it's pretty hacky. And we have another Twitter account for Pester specifically. I would really like to have just at Pester, but that one is unfortunately already taken, so it has to be PS Pester. Now, one thing that took me a while to understand is that testing is very simple unless you make it difficult for yourself. And you might be wondering, what is this testing thing about? That's probably why you are watching this talk. And believe me or not, I was in your shoes before. I didn't have any experience with testing. I didn't have any experience with development. But I got a very difficult project to do, and I had to finish it somehow. And at that moment, I thought I know PowerShell. I know a lot about the language, but that wasn't true at all. And so after a week on the project, I started realizing that this won't do, that I won't be able to finish the project unless I change something. And I thought, well, testing could help me because I always was fond of stuff that developers do. And so I started looking around. Is there anything like testing in PowerShell? And at that moment, at that point in time, there were few testing frameworks. One of them was Pester. And to me, it seemed like it's the most feature-rich of the 5 frameworks that were there. So I just chose Pester to start testing. And it seemed really confusing because I had no idea what to do. I had no idea what testing is. And I had to grab everything and understand it and start practicing it. But fortunately, now you have me, or you have a lot of other people who are publishing a lot of content about Pester that should help you start. So at least understand that it is really simple. There is no magic in it, and I think I will repeat that a few more times. So first thing that you need to do is to install Pester, or in fact, you don't really need to do it because Pester comes on Windows 10 and it's built in. It's kind of old version, but you can still use it. So on every Windows 10 machine, there is already Pester in, which is, I guess, great thing to have, and it's awesome achievement, but well, I recommend updating anyway. So if you want to update, then you need to run install module, specify the name Pester, at least on Windows 10, where you have this whole install module thing available. If you are on earlier versions, you can use psget or you can use NuGet to get your modules. It really depends on what you have available. One thing that's important is to use the minus or dash skip publisher check switch on the install module, because otherwise it will give you just an error and you won't be able to install it. And also use the dash force parameter, because otherwise it will complain that you are updating and won't install anyway. So usually we would start with some theory of testing, and I would describe what a unit test is and what an integration test is and so on, an acceptance test, and we would talk about DDD and stuff. But I don't think that's necessary as a first step. You will then be faced with a problem of where do I start anyway? So let's just start and let's just try it out, because I did it that way. It was a bit difficult for a while, but then I started realizing what the concepts are and it started to clicking together, and you really need to learn by doing. So let's at least set some free rules to follow. So the first is state what this is and then just check if the output is that. We will get more to it to give it more sense, but basically that's what the testing is. You just give it some precondition, that could be some input value, and you do something about it. You run it through a function or you run it through a couple of functions, and then you get some output or you get some behavior and you validate that. And that's all. That's pretty much whole testing. Then my problem usually was that I got it too complicated. I got everything stitched together, and I got some dependencies that I wasn't aware of and so on. So I always tend to keep it simple. And it's really good if you are able to write, I don't know, 500-600 tests and still know your way around it, know there is no dependencies between those tests, because then you have a test suite in great condition, and you could basically just take your production script, throw it away, and rewrite it just by having the tests. So just for yourself, keep it simple. You're learning this stuff, so don't complicate it for yourself. But also don't get too strangled about rules and stuff, because, well, just have fun and play around with the language and with the concept and with the testing framework. And to be able to do that, keep it readable, because readability is one of the main things in testing, because tests are also documentation. So if you just put in there something that says it does something, or if you name your test, it does the right thing, or negative numbers, then it will be really difficult for you to understand what is happening and what you are trying to achieve. Because you won't be reading those tests just now, you will be reading them in a few months. You might handing your script or your product to somebody else and just tell him, well, go through the tests, you will see what it does. And then you give him some small explanation, definitely better than just giving him 600 pieces of tests that says does the right thing. For Pester syntax, it's really simple. Sorry. We have just 5 words that we need to use, and I will go through the syntax and then I will show you how it kind of looks in the language, so you have some chance to understand what's happening. So the first keyword is should. Should is a so-called assertion, and you use it to check values. So you give it some value and you give it some expected value and you check if those values are the same. So you would use it pretty much as this. The first line, that's just some code processing, so I just don't show you 1 should be 1 or something like that. So you give it some hashtags, you run it through your function that's called replace hashtag, and you replace it with asterisks. And so in the end, you should get 3 asterisks instead of 3 hashtags. That makes sense, right? So we use should be, which is basically just an EQ operator internally to compare those two values. And if you look inside of the implementation of should, or of should be actually, you would see something like this. So it's just an if, And the if compares the expected value and the actual value. And if those are not the same, that's the important part, it's not the same, then it throws an exception. If they are the same, then it doesn't do anything. And there are a few things to notice. One is that the expected is on the left-hand side value of the NE operator. That is to force the comparison to use the same type. So if you're expecting a string, it should be compared as a string. That's just a implementation detail, but it's quite important if you're writing your own assertions. And then the other thing is that it really does nothing if you pass it to values that are the same. That's something that trips up a lot of people, even the developers that I meet. They think there is some secret language that the assertion uses to talk with the testing framework, but really there is not. It's all just built on exceptions, because the exception, or in PowerShell we call them non-terminating errors, the exception is used as a universal way of communicating some error, because basically there are three ways your code could go. The first way is that it completes to completion, it runs to the end, and it produces the correct result. That's what you want. It's like doing 1 + 1 and getting 2 at the end. The second way is that it runs to completion and produces an incorrect result. So that would be like adding 1 + 1 and returning 3. And that's what we want to catch with the assertion. So we take that and we convert it to an exception, because the third case is that your code doesn't run to completion, so it must throw some exception. And so we're just adapting the 2 second cases to the same thing. So we have just one unified way of communicating an error to our testing framework, because throwing an exception is much more usual than having a incorrect result. But that's just some theory that you don't need to necessarily understand. It's just about understanding that exceptions are the driving force behind assertions. Then we have another keyword, and that's it. And this one is probably what makes the testing framework the testing framework, because that's where you put your assertions in, and you can replace should be with custom assertions, but you can't replace it with custom it, at least not with re-implementing it as a whole in Pester. You could do it in different testing frameworks, but not in Pester. So it just gives you a name for a block of code, and then inside of that block of code, you put your test code. So here again, we are using the same example as in the previous example. We are replacing hashtags with asterisks, and we put it inside of a block. So if we run this now, if we didn't have the next keywords mandatory, then this would run the code. And if the replace hashtag function exists and does the correct thing, so it completes with the correct result, we would just do nothing. We would just print a green result. We can look at how it's implemented. This is really the gist of how it really looks inside of the framework. So we have a try-catch block that helps us to catch the exception from the assertion or the exception from the code. And what we then do is that we use the execution operator to run the test block, and we throw away all the output. And if the test block doesn't throw any exception, then we go to the next line and we print the green result, which is the name of the block. And if it throws any exception, then we print a red result. We would, of course, also print the message from the assertion, but this is the very, very basic concept of how it works. There is no magic in it. Next two keywords, which in Pester 4 are the same thing, are describe and context. And describe and context, we don't have to think about them that much at the start. They give us some scoping and there are some rules about it, but we can just think about them as way of grouping stuff. So usually we use describe to group tests that aim to test one function. So in this case, we would add describe replace hashtag. And if we had a lot of stuff that we want to test about our replace hashtag, and it would make sense to put it in different groups, then we would probably use context to give more context to our tests. So if in one place we are trying to test if it replaces correctly, and in other part we are trying to test if it throws exceptions if we give it null input, or something that's too long, then we could put it in two different contexts. The first context would be replacing, and the second context would be called input validation, for example. Now, if we looked at the implementation, this is really, really simplified because the describe does a lot of setup and it does a lot of teardown of different services. But at its core, it's just executing the code that's inside of the script block and gives it some name. And there are also try catches and finally and so on, but we don't have to concern us with that at the moment. This is quite simplified model, but I wanted to include it anyway. And the next keyword, maybe the most advanced from all of those, is mock. And we will use it in my examples, and it's for faking dependencies. So if you have some function that you want to replace with your own implementation for different reasons, we will go into those later in the presentation. You can use mock to basically redefine the functionality or to guard yourself from doing something bad just by running your tests. For example, you want to hide remove AD user from your test framework so it doesn't do anything. So you can't accidentally delete users from Active Directory just by running your tests and having the possibility to do so. I mean, the rights to do so. So in this example, we want to stop antivirus service, and we are admins, and we can do that on our machine. We maybe are running as a system, I don't know. But we want to guard ourselves from doing so. So we add a mock that just applies to every call of stop service and replaces that with doing nothing. And then we call our own function that we are testing that just selects from all these services the antivirus service and runs stop service on that. But during the tests, we don't want to stop the real service. We just want to validate that it calls the stop service as it should. So this is just a simplified example to go with the other ones. This is very simplified way of how it would work. Inside of Pester, it works kind of differently. It creates aliases and creates random functions and replaces them. It uses different mechanism than defining a new function to shadow the previous function. But the behavior is almost the same. So you can think about it that way. So on the top, we have the built-in commandlet that's remove item. And then inside of our tests, we are shadowing it with a new function that has the new name. Has the same name. So if we then, on the last line, call the remove item, instead of picking up the real commandlet, we pick up our function that we use to shadow it. So we will hide the functionality and we will do nothing. But don't worry, it's no magic. I said that too many times already. So let's start with the practical part. And normally I would probably show you some calculators and adding one number and second number, and you would just say, well, why should I state the same thing twice? And this doesn't make any sense. And with the calculator, it doesn't. Because, I don't know, I would ask you to raise hands, but I can't see you. But you can do it for yourself. Raise hands who implemented addition in your language. I guess nobody, because it's already built in. So if you write the calculator, there is nothing to implement, and you're just validating that you know how addition works. But that's not how we use it in practice. What we do instead is that we have some goal that we want to reach, like writing a function that replaces hashtags with asterisks. And so we state that goal, and we split it into multiple small goals, so multiple small criterias that we want to use and put in our test. And then we put them in our test. So we just write a new it, we say this should do that, and we add the code that validates if we give it the input and that we will get the expected output. So before we go even into the testing, I need to set some context, and you don't have to understand this too much. It's just real life example, so I want to give you the real life context of that. So a few days ago, I was writing some scripts, some build scripts for this tool called Jenkins. And Jenkins is a build server, and what such build server does is that it just builds steps. So it takes your code and builds it. So it could be, for example, an ASP.NET website, and it creates the DLLs, and then it creates DLLs for the tests that you have. It runs the tests against your website or against any code that you have. And when everything passes, then it packages up the application, for example, into a Docker application, Docker image, and publishes it somewhere. So, for example, to a Docker registry. The exact way how this works is not very important, and the use case that I'm using it for is not very important. What's important is that it just does some steps. And those steps can be different. So we can have the first step as PowerShell, and we can set up the environment. Then we can have a command line build step, and we can run the build there and do the tests there. And then we can have Docker command line where we can package and publish. But what we have around that is one environment that is shared. And it's kind of like the env environment variables in PowerShell, but not exactly that, because those are not shared through the whole runtime. So we need to create a special file, and we need to put code, put values in there in a special format. And that's what I was writing my code for. So the environment variables in Jenkins look like this, and we will be transforming some names to this format. And that was one of the basic tasks that I identified and started from. And another concept that I also need to explain is versioning, or in this case, semantic version. How it exactly works and what the semantic in there is, you don't have to understand if you don't understand it already. What you need to understand is just look at this format, and you can see that on the first line there is a normal version. On the second line there is a version with metadata that is a short hash of a commit. We will do that as our first task. And then we have some pre-release versions of our software that state when it was packaged and from which commit it came and from which branch it came. Just look at this format, and you don't have to know much about it. Just get familiar with how it looks. Now, to achieve this versioning, I'm using a tool that's called Git version, and it has quite complex behavior internally, but we don't have to understand that again. We only need to understand that it produces an output that looks like this. So it's a simple JSON object that has some properties, and you can already identify some of the values that you saw in the previous slide. So we have the pre-release tag, which is beta. We have the version, which is 0.1.0, which was on the top of our string. We have the branch name, which is also beta. We also have the SHA hash that we had in the shorter format in our version. And then we have some commit date that we can use, but we will generate it ourselves from the build currently. So this is kind of the edge between this tool and our application. And you will face this a lot, especially in PowerShell, because PowerShell is all about integration. So you have one set of commandlets that manages SQL Server, and then you have your code that you want to apply to it. But you're not communicating with SQL Server directly. You're just running the commandlets. And so the commandlets either produce some values or give you some kind of results. So you basically don't know if you're talking to a real SQL Server or if you are talking to a really clever machine that just returns you the right values and in fact does nothing. And so there is a boundary between your code and the other code that you need to identify, and you need to ask yourself, how much do I trust this Git version or this SQL commandlets that they do what they should do? And by looking at the Git repository of Git version, I saw a lot of people use it, and it's probably very well tested, and it's tested just by using it by a lot of people. So if a lot of people use it and it works for them, you know it works somehow. I just needed to understand how it works. So this is where the boundary between my code and the Git version is. And so I can just simplify it to just consuming it output. But let's start with something really simple, and that's converting the Git hash to a short hash. So here is how it looks. Here is a hash that's normally quite long, and for our version, we want to shorten it to just the first 7 letters. So we want to write some tests for that. So let's switch to code. If we have it somewhere, this should be it. No, sorry. This one is it. So here we again see the familiar, I will just clean that up. The familiar syntax that we learned about in the start of this presentation. We have described that puts there the name of the function that we are testing, and then it states what exactly it is testing for. So normally we would have quite a long list of the its, but we will just simplify it to just one it per function, so we don't spend too much on testing one function. We just use it to highlight some concepts. So I got a long hash, which is something that I, for example, copied from some Git repository, and then I run it through my function that I'm writing. And what I expect is to get back the first 7 letters. Now, you can think for a moment how you would implement that. What is definitely needed to do is that you run the test first to see that it fails. And this is great because now we know that we are missing some functionality in our function. We knew that already because we see there is no code. But if we run the test and it passed, then we probably don't understand what's happening and what's exactly in our code base. So if we added a functionality and we already had a lot of code on this side in the production code, then we might not fully understand what our code does. So what we want to do, and this is part of TDD, but I won't be sticking with TDD too strictly, is that we run the test first and we see that it fails. And even more importantly, we want to see it fail here in the assertion, because it's not enough to just have a test that just fails. Because now, come on. Now we have just a broken test that doesn't validate anything, but that's not why we write a test to make it red. We write the test for this assertion, so we can validate one very small slice of functionality that we want to have in our production code. So you really have to pay attention to where your test fails. And now we can start implementing our function. So I will just guess, and I will just say, well, hash is a string, so we can just index in it. So that will be hash, and I will just go 1 to 5, save it, and try if it did what I wanted it to do. Oh, okay, so, well, it should start from 0, right? So let's start from 0, and we want 6. So 7 letters, so that will be 6, not 56, just 6. So let's start it again. And I see we are getting the right thing, but there are spaces in it, so it must be an array, I guess. So we need to join it inside to make a string. And then we run it again and we pass because we gave it some value, we did some processing on it, and we did the right processing, so we got the correct result. And this is pretty much how you do it in testing. You just state what you want, and then you just check if you got what you wanted. But you can notice that I ran the tests a few times. And first, it helped me to understand what my code is doing. I didn't have to click here and, rerun the function or select this and press F8 to run it in the console and do some setup. No, it allows me to run my code very quickly once I do the setup in the test. So I can now run it 5 more times if it's going to run. It's quite slow in the Visual Studio Code. And then in future, if somebody goes here and changes this to 5, then I get a message that something changed because somebody broke my code. And that's great benefit if you have something that does something very complex, like my first script that brought me to Pester, because then you don't have to work on it for a few months and you get the fix, and then you just go back, you run your tests, and you see what your code does. It reminds you what it did, and you see it still works. And then you start doing changes and you start understanding again what you even did in the code. And it stops you from making a lot of mistakes. We fix that again. That's great. So let's switch back to the presentation. Now, if you guessed what I did, what I was going to do, and you had the code in your head correctly, then just pat yourself on the back because you deserve it. So if we lift up what we just did, we can see that we took some input and we processed it in some function, and then we got the output, and the output is what is in, I'm sorry. The output is what is interesting to us. That's what we inspect. And this kind of function that gets everything by its input and puts everything to its output is really easy to test. Because when you don't have any so-called side effects in it, when you don't take data from anywhere else, so you don't generate random in it, or you don't load it from a file, or you don't read it from an SQL server inside of the function, then you have some function that's deterministic. So you can give it an input, you can process it, and you can validate the output, and it should always result the same way. So if you give it 1 and inside you add 1 to it, you will get 2. And you can run that as many times as you want, and it always will be 2. So it's really easy to test. And if you recognize the shape and you start writing your functionality in a way that most of the functionality is inside of those functions, then you will start realizing that it's quite easy to test the decisions that are made in your code. So this shape of function is usually what you are aiming for. It can make the function a bit difficult to use because since you can't call anything that has any side effect, so you can, for example, get item from a file system because the file or the file system could change, then you have to pipe from get item to your function and so on. So this is not what you usually surface to the end user. You kind of hide it inside of your module, but you compose your module from functions like this, and it's much easier for you to test it. Now we have another task, and this task is very similar to the previous one. So we have to convert name of something to Jenkins environment variable format, which you saw before. It looks like this. You don't have to do it. You can call it whatever you want, but I just wanted my environment variables to look nice in the script and look the same way as any other environment variable in the script. So I have the string NuGet version, and you can see that I have capitalized the N, I capitalized the V, and then I change it to format where everything is capitalized in the word, then underscore, then capitalized again. So again, think about how you would write the function. I will switch to the code. And this is where I will put the implementation. So that will be the production part. And here is where I already prepared the tests. And now the task is pretty much the same thing as we did before. What I want to highlight in this example are those test cases that you can use. And test cases allow you to reuse the internals of the test for multiple values. It's very useful, especially for those functions that take the input and produce the output and do nothing else. And I usually tend to write all my tests in this format that it uses the test cases, because then it's really easy to go here and add another test case. You shouldn't overdo it. You shouldn't have few hundred test cases, because then you are usually losing the context. So either add comments to groups of the tests, or even better, split them into multiple its. So you can say, here I'm handling negative numbers, and here I'm handling positive numbers, and here I'm handling empty strings, and here I'm handling something other. So you don't lose the intent. For example, in one of my modules, I'm converting string false to actual false, which is not what's happening in PowerShell, right? Because when you have, whoa. So this results to true. And in one of my test cases, I'm saying, well, this is the input value, this is the output value, and then suddenly string false should be equal to false, Boolean false. And if you look at it, it doesn't make sense, especially if you know about this behavior. So it's much better to capture that into some other context and give it explicit comment that says we are changing the behavior of the default here. So you don't want to overdo this. You don't want to specify a few hundred test cases. Usually about 5 to 10 is fine. Because if you do specify too much, then usually this description of the test is too generic, and you should make it more specific. So all the test cases don't fit with it, and there is only 5 test cases that fit with that description. But let's go on with our task. So what we are doing here is that we have a hash table, and notice this array here, which enables me to format it more nicely without using those ugly backticks. And in that array, we're providing hash tables. So this hash table has a key value and it has a key expected. And then by naming convention, what we can do is that we replace this value in here. Those less than and greater than signs are significant. So those are the boundaries where it is replaced. So basically by this, you say, put here the value key from the test case. And the same for the expected. And then again, by the naming convention, we are also expanding it to the parameters of the script block. So if I run this test, it will run this code twice. First with those values and second with those values. And that's exactly what happened. So we can see, well, we expected NuGet version, but we got nothing. That's expected because there is no function. But again, we failed in here in the assertion, which is quite important. So we can start implementing it. And at first I thought, well, let's do some splitting, right? So let's just split the name and on the capitals and so on. So it's not like the code comes naturally to me and I'm just genius and I just spit it out. And I expect maybe you do the same thing. So you just experiment, and testing is great for experimenting, but you should still think about what you're doing. So I gave it the name and I did split. And well, I split it on A to Z. And well, then it does nothing again because, yeah, split is non-case sensitive by default. So now we're just replacing all the numbers or splitting on all the numbers, so that can work. So we need case sensitive split, but yeah, that still doesn't work because then we lose the letter. So that's not a good idea. So if we can do split, let's try replace. That was my second choice. So I can try replacing it with underscore. I will still lose the letter, but I can solve that later. So now I'm kind of getting there, and now I had to think about it. But you can see that you can just experiment. You can just run it 5 times, and that's the great thing, because this will run the same all the time. There is no way you make mistake just pressing F5, but you can make mistake running this in the console and putting the values directly in. So this automates what you are doing quite nicely. So what we can do is that we can actually put this into a capture group, and we can then expand it, I guess, as the first capture group, and that could work. Yay, so we're getting almost there. Now we just have one extra underscore on the top. So we can do that. We can just trim the top. I'll just put it on the next line. Let's trim start to be really explicit about what we're doing. And yeah, now it says we are there, but well, that's a bug, right? So we need to change the test, and it needs to be beat exactly. Oh, sorry. Because now we had a bug in our test, and what you want to do in this case is that you either touch your tests or you touch your code. Don't do the don't touch both of your code and both of your tests at the same time without running the tests in the meantime and going through the output. Because if you do that, then you lose the track of what's broken. So if I just change this and then change that, and it started succeeding all of a sudden, and I would have no idea what's happening. maybe in this really simple case, I would be able to fix it very easily. But if you have 5 tests failing and you touch both the code and both the tests and you don't run the tests in the meantime, then you will have really hard time finding what's happening. So we almost got the string. Now we just have to convert it to upper. So to upper. And we're there, which is awesome. So in this case, we did the same thing as in the previous case. We had a function that takes input and produces output and nothing else. It was just to highlight the test cases. Now we have another task, and we have to compose the version string that we saw before. Oh, sorry, there's no example. And for that, we need to somehow stabilize the way the Git version works, because the way the Git version really works is that you have a Git repository, you stay inside of that folder, you run Git version, it looks at your commit history, determines on which branch you are, and from that it selects based on some criteria and configuration which version should be the next, and so on. It really sounds really complicated, right? But we don't want to concern ourselves with anything like that. We just want to be sure that we converted the incoming values to the correct format. So we want to stabilize what the Git version does, and we also want to simplify the setup, because if we test it against real Git version, then we would have to create the repo every time. We would have to put it in the right state. And that's, well, not expensive, but it's unnecessary because we only care about the particular output and validating if we transform that output in the correct way. So what we could do is that we could just compose the functions using pipeline. Where is that example? Let's just move that here again. And so we could take Git version, call it, take its output, convert it to JSON, and we could then pipe it to our function that would format it. That would make it quite difficult for the users, and we wouldn't be able to highlight how mocks work. So we will do it in a different way. We will put the Git version XZE directly in our function, and we will fake up the Git version. And then we take that output and we convert it from JSON. And we use our get short hash to take that from the version. I hope you still remember how the output looked. I will just scroll back to it. So this is how the shortened output from the Git version looks like. So we take the SHA hash and shorten it through our function, and then we have through other properties available. And what we want to build from those properties is this kind of string. Building the string is quite simple. What is difficult is stabilizing how the Git version works. And for that, we use mocking. I'm on the right incorrect example in here. Yeah. So as I said, mocking just hides the functionality of the other commandlet. So we specify a mock by the keyword mock, and then we specify the name of what we want to fake. And in this case, you have to use the .xe for Pester to be able to pick it up correctly, I think. And you have to do the same thing in here, specify the git version .xe, because otherwise it won't work. And then we say, well, we don't have to use the real Git version. We just captured some output of some run in some other real environment, and we saved it, and we want to replay it when we call our code. Then in the example, we also need current date. So we do the same thing with get date, but instead of putting a recorded output, we are just creating a new date time and we specify some date. Now, word of caution here, if you call the get date inside of the mock in order to create the datetime object, it will just it will just call itself again and again, and it won't do nothing and it won't terminate. So you have to find different means of creating the object that you want to produce than calling the function that you are mocking. And then, as in any other test, we are having some expected value that we expect the mock and the function that we have will produce using the mock and using the data that we gave it. So it's kind of the same as in the previous two examples. Only the data don't get inside of the function externally, they get to the function internally through the git version and get date, and everything else is just part of this either or not consumed from any external source. So we are hiding all the external sources of information to stabilize what we are doing. So what we need to build is quite simple. Well, first we run our test to see if it fails. And we see that it fails as expected because we wanted this and we didn't get anything. So now we just need to build it. So that will be version, and that's major, minor, edge, as we can see here. Then we add dash to it, and we add the pre-release tag. We add the date that we already formatted. And there is a dot in between, so we add the dot. And then we just add plus, and then we add the short hash. But well, let's not do that yet. Let's pretend we wanted to run the test in the middle. And we can see it produces the right result up until the point where we are missing the short hash. So we are on the right path. And we successfully built that string by mocking the output. So again, what we did is that we stabilized the dependency. So instead of using a dependency that's hard to obtain, for example, like setting up a Git repo for the Git version, or in another example, say we wanted to have nicely formatted list of SQL users, and we wanted to write a module for that, and we wanted it to process correctly outputs of SQL Server 2016 and 2014 and its commandlets and say they are different. So we don't want to install two different versions just to be able to process some output. We want to just capture the output from each of the versions of the SQL Server and then just give it to our programmers and just say, well, transform this from this to that. And that way we stabilize the dependency, even though we lose some of the fidelity because the format can change in the real version. But there is pretty good chance that it won't change. So we make our life much easier. So the scheme for that would be that we have a mock that produces some input and we go through our function and then we inspect the output. Now, in task 4, we are taking the result of our build and we are building it in a Docker image. Actually, it's called package here, but well, it's the same thing. So let's call it Docker package. That's out of place, I guess. Let's see. To build that package, we need to call some functionality, some command line of the Docker, and that would be a command docker build, and then we would give it a Docker file and some place to run, and it would just create an image. And you don't have to understand that much. Just understand that there is some underlying dependency that we want to call with some correct parameters. So for that, we are writing a function like this. And see, we are getting a bit advanced. Where's the code? So we have a function that's called new Docker image, and we want to use it to build our Docker image. Now, there are a few things to notice. First of them is this build Docker image function, or, well, it's not it's a function in here. Here is just a mock. So we use this to wrap dependencies that are difficult to mock. So we make it much easier for mock to handle and for us to handle in code. And it also makes them adapt nicely to PowerShell. So normally I would just call Docker build and then with tag and gave it the tag and then the place to run. But this would be hard for me to mock because then I don't have all the parameters named and it's just an XCE. So I rather wrap it in a function that just calls forward, and then I mock this instead. Then the other concept is that we have a guard mock, and I already mentioned that before. A guard mock just prevents you from calling the real function, so you don't break your environment. And you could take it and you could put it in here inside of the describe, so it would hide the build Docker image from all of the tests, and it would just do nothing. So this is the same as just specifying do nothing, because that's the default value. And then we have some worker mock, or it doesn't do much work. It's just the mock that we use for the test. So here we specify, again, the name of the function that we're mocking. And we are specifying some parameter filter because that's what we need to verify the behavior, to verify that we are calling the commandlet or the function with the correct parameters. Because in the end, that's all we have to do when we have a clear boundary. We just need to invoke a commandlet with the correct parameters and believe it will do its work. And if it won't do its work, it will give us some exceptions. So to validate the behavior of commandlet that we trust, we just need to verify the parameters that we are passing to it. So here we have the filter, and the filter says the tag, which is, this tag parameter here will be this value, and then the path will be just the dot for the current directory. Then we have our function that does the functionality that we are implementing. So this function is just a helper that specifies the boundary for us. And then we have this function where we would have all the rich functionality that we want to implement. And then in the end, what we want to validate is that the mock was actually called and that it was called with the correct parameters and that it was called just once. So we don't build the package twice. So that's what we're specifying here. The parameter filter is exactly the same as in the mock. And then we say we want to call it ×1, so just one time. And we want to call it exactly one time, because if you didn't specify this parameter, you would say you can call it at least one time. And we don't want that. We want that exactly one time. So all we need to do is just to build the right version in here and just pass it on to the build Docker image. So again, let's just run our tests. And we get a breakpoint, okay. And we can see that it failed. It says that it expected build Docker image to be called 1 times exactly, and it was called 0 times. And again, we failed in assertion because this is a assertion. And so all we need to do now is just implement the functionality. So I already have the name, I already have the version, so I have the whole tag. I just need to pass on the values. So the tag will be, of course, the tag, and the path will be the path. And we can see it passes, but you could notice two things. One is that if I just put the dot here, it would just validate the same thing. So that's one of the concepts that TDD teaches you. Implement as little as you need. So we would need much more test cases on this side to validate all the behavior. So we would probably specify some test cases. We would give it different paths just to validate that we are not returning just the default. And another thing that you could notice is that for the get version, we don't specify the path. But as we told before, the get version depends on git version, and git version depends on the current directory where the repository is. And this is one of the downsides of mocking. You are losing the real fidelity of how the underlying stuff works. So you have to use it with caution, and you have to understand what you are doing and what behavior you are providing to your tests. Because if I run this on a real environment now, it will just take the get version from the current directory, but I can specify a path to a different directory. So then in the end, I would have a broken behavior that would probably be some bug, and then I would have to add some test for it, which is also a nice way of evolving your software, that you add the test first, you check that it fails, and then you implement it. That's kind of what TDD teaches you, or test first teaches you. So now we verified the behavior of the Docker build because we just said we want to do that. We want to invoke the commandlet with those parameters. And then we only verified that we invoked the commandlet, not that it did the real thing. You probably do want to write at least 2 tests that will do the thing from the start to the end with the real dependencies, or have some manual testers that will do it for you. Because all of those tests now were just unit tests, and I didn't want to go inside of the specification, but we can see that they were isolated and there was a lot of room for hiding the real behavior of the real tools. And in the end, we don't want to write tests just to make the tests pass. We want to write tests to make the chance of running in the production bigger. So to replicate the production behavior more precisely and to verify it from a lot of different perspectives. So now you can see on our graph that we did something similar to the previous case, but in a different order. So we gave our function some input, and then we inspect the mock, or in fact, how the mock was called at the end. So we are verifying if it behaves the way that we want. We don't have any output. This one you use usually for functions that you use for the side effects. like removing an item or adding a user to Active Directory. Usually, even from those, you get some output back. But then you would still split this into different use cases. Because if the dependency is real and you give it some parameters and then you mock it out and you return some stabilized value from it, then you didn't verify anything. What you want to do is that you check that you invoked the commandlet with the correct parameters. And that's what we just did. Now, task 5 is not testing per se. And I wanted to highlight that even though all of those tasks were quite simple, I spent a lot of time looking at how Git version works. I was playing with the code. I was trying to understand it. And there's no shame in that, because usually it looks like people just pick up the code, start banging the tests, tell you that TDD is everything that you should ever do. And they will just show you simple example where they, I don't know, build Fizzbus or something like that. And then you feel bad that you don't do TDD, and you feel bad that you are not as awesome as the people in the presentations. And the truth is that I spent a lot of time playing with Git version, writing a lot of code around it, checking how it works, writing a lot of really ugly code. And when I almost got it working, or got it working in a way that I wanted, then I just took the code and threw it away, or I kept it, but I didn't use it anymore. And then I started writing it again with tests. And I started from the top. I wrote a test that validated it from the start to the end on the basic behavior. And then I started writing smaller tests that tested stuff like, I provide null value here, will it fail or not? I provide empty string here, will it fail or not? And so on. So it's not very straightforward, thing to do. And testing is about learning. And what you can also do with testing is that you learn about the software that you use by writing tests for it. So basically, as I highlighted before, to really use Git version against real dependency, we would need to create a Git init, and we would need to create a Git repository. We would need to make a commit and so on. And we make a lot of mess in that process. We produce a lot of files. And to store files and delete them, we can use a feature of Pester that's called test drive. So it's available as the test drive that you have. It's a PS drive, so it has this nice name. Or, sorry, or you can use it as $test drive if you need the full name, especially if you're communicating with .NET code. And then you can put any files in it, because at the end of describe, it will just throw all the stuff away, so you don't have to clean up yourself. But what I want to highlight here is that I write this test, which would be an integration test, and I run it against some real dependency, because I'm trying to understand how it works. And when I understand how it works, I can just keep those tests, because they will still validate that it works the same way as when I was exploring it the first time. So then if the guy who writes Git version or the community decides to change the behavior, and I didn't stick with just one version and I will update it, then I can run the tests and validate that it still behaves the way as it did before, because that's the way that fits with my code. This is called discovery test, or at least I saw it called that way sometimes. And you can use it to stabilize the external dependency. I just look if we have an example for that. Yeah. So this is just the same code as we had before. We're just running some code against Git version, and we could write a lot of tests like this. And usually we start from this and we just see what it does and what type of output we get. And then we put some scenarios in here. So what I'm verifying in here is that I create a new Git repository. I start and I check, well, I first run this code and saw what the output would be. And then I stabilized it in here as the assertion. So now I know when I initialize a new repository, the first version will be 010. And then I learned about Git version that we can change the version by specifying a tag and putting it on the current branch, and it will pick it up and change the version. So I wanted to verify that as well. So I just put it in here, did a new tag, and then I run the Git version again and verified that it actually happened. And as I said, if I keep this in my repository, then it will validate that it still works the same way, and I can be less surprised when the dependency changes in the future. So this would be the scheme that we're using. It's pretty much the same as in the first example where we put some input in, we process it through some function, and we get the output that we validate. But in this case, the function is not something that we implement. It's a external dependency that already has its own behavior. We're just trying to capture it for ourselves so we can keep it for the future and keep the dependency stabilized. Now, if you want to get the code, it's available on my GitHub repository under no-hbnd/introduction to Pester. And I have to warn you, I simplified the examples a lot. And the code that you will find in the introduction to Pester is the code that I've shown you. But it doesn't necessarily work with the real dependencies because, for example, for the Docker tag, there were some characters that I needed to filter out and so on. So it's all quite simplified to work with the real examples. So don't use it in production for anything else than just learning Pester. And well, experiment and have fun because that's the most important thing. So that's it. I don't know if there's any window for QA. If there is, then I will be happy to answer any questions.
Can you hear me?
I can hear you.
Hello?
Yes.
Okay, but are you still recording on the YouTube?
I am recording, but I think you can close YouTube and we can just talk through this. I will just still broadcast it. Yes.
Okay, but are you still recording on the YouTube? Okay, let's have this. Okay, now. Can you hear us? Me?
I can, yeah.
Okay, so now you are on a laptop. So any questions, guys? You can just ask.
So if there are no questions, let me just ask the audience. Did you get anything from that? Was that too confusing or was it easy to follow? Who think it was easy to follow, then please raise your hands. Okay, I see a few hands. Is that the majority? Because I don't see the whole room.
Yeah, I think. Yeah, most of the people.
Oh, that's awesome. So really, no questions?
I have one question.
The
mock, right? The mock command that you used, is it something like confirm or what if in the
I'm sorry, I have a bit trouble hearing you. Either Confront or Sebastian, please repeat the question.
He's coming from easier.
Hi, can you hear me?
Yeah.
Okay, yeah, my question is about mock. So you say that the command doesn't actually do anything, but it can simulate the action. So it's kind of yeah, I'm trying to figure out how it works. Maybe if you can give some real example. Yeah.
So
That
are you
would help.
and how mock works internally, or how to use it?
Yeah.
Both?
For example, if you want to go to a database to expect a value coming back from the database, so you analyze that value. So you're mocking a function that actually doesn't go to the database, it just returns the value that you expect from the database. So to make it self-contained.
So I give what is the input and what is the output. I specify the output myself, or how does it? I mean.
So you use the mock to just you don't use it in a way that you would go through it. So you only either ask it for a value or you call the function and then you validate the behavior. So if you have those tasks, like I want to call a database, then you would split it into different tests and you would specify the mock differently. So if you call the database, then in one instance, you are verifying that you are calling the database commandlet with the correct parameters and correct values for them. And in the second instance, in another test, you can specify that you are processing output of the database correctly. So in the first case, you would do the assert mock call. And in the second case, where you are validating the values, you would output the values from the mock, but you never do the two things at the same time.
Okay, so let's say I want to mock the data from the database. So without actually, knowing what is there in the database, how does it going to give the output?
You are not touching any real database. What you will do is that you will either create the output yourself, or you will take some database that has the real data. You will query it with the commandlet that you are mocking, and you will store that output. And for example, as a CLI XML, and then you will output it inside of the test. So you stabilized the state of the database.
Yeah,
so
okay. I
only
think I
have
got it.
one exact output that you will get from it. It doesn't touch the database.
Okay, yeah.
And if you care about how it works internally, it's basically just aliasing to a random named function in the current version. So the alias takes precedence over everything else, and the random function is there just to avoid conflicts. And then inside of that, there is some code that counts how many times you called it, or optionally calls the real function if you want.
Okay, yeah, I think that clarified my question. Thank you.
Okay, great. Any other questions? Doesn't look like so.
Yeah, looks like no question.
Okay, in that case, it was very nice to present to you. And hopefully, if there is any interest in Pester, we can see each other again in the future.
Yeah, I hope see you on the PowerShell conference.
I wanted to go there, but I'm not in the end.
Okay.
Next year, maybe. Well, hopefully.
No worries. Okay, thank you very much for your time, and yeah, have a good sleep now.
Thanks. It was a pleasure. Bye.
Okay, see ya.
See ya.